first thing that I do in general is to make sure I open MMDetection here. So I already put it on VFNet, and the way to get there, you see that in the repo, I don't know if you are familiar with the MMDetection repo, on the root folder you have config, and under config you have the configuration of all the models that they support. And there is a base. It's like the other models can inherit from the base, and under the base you have models too. So you have Cascade, mask-rcnn, Cascade, RCNN, and so on. And there is no VFNet because they don't share with like other submodels, different kind of models. So what I do, I go and just check for the one that I'm interested in creating. So here it's VFNet, and you can see that VFNet has here 8 different configurations. Okay, if we go to the repo here, embed the configuration, we will have the same thing. But why I'm opening this, it's because here we have more information about the models that have already pre-trained weights. So those are the different models so we have 8 in total. We will come back here. Okay, so I open IceVision. Here I already implemented the whole thing. So I'm going to show you the end result and then we start over. So the whole thing is if you check under, so here we are under model. So let's go step by step. We are under IceVision, then we go to model. Under model, there is MMDet, raw storage vision, and so we go under MMDet. After that, there's models, and here those are the ones that are already supported in IceVision. Here I'm working in a branch, so this is why VFNet is showing up. If you start with master, you won't see that. So you see that there's CornerNet, faster-rcnn, FCOS, and so on. And we want to create another one, VFNet. And all those folders, they always have backbone. They have init. And under backbone, okay, let's not take RetNet because we added some other stuff, but FCOS. So backbone, also init, and ResNet FPN. And here we have to recreate the ones that shows up here. Okay, so we are going to create for each backbone this MMDet. So here it's called MMDet FCOS backbone, but for us it will be MMDet VFNet backbone. And there we have just to add some information. The information that we need is the configuration file, the path to the configuration file, and the path to the pre-trained weights. Okay, so let's switch to master. So as you can see, what happened? It keeps like a cache here, but it's fine. Okay, so let's create a new branch. Usually I choose something that starts with MMDet, so it will be MMDet, and then VFNet, the name of the model that we want to support, and I add support. And I will add here, it's like test, the one that I'm going to show, because afterwards I'm going to delete it because I have already that. Okay, so if we go here, FCOS is here, VFNet is here. Okay, this I'm going to delete, and hopefully it won't delete. It shouldn't delete my. Okay, I did something. Anyway, it's done and it's Friday. So what we have to do is just to make a copy of one that is of the same, not even the same family, but let's take FCOS and we'll create a new one. Then we change the name. It will be VFNet. Okay, so we have everything here, but what happens here is that if I go here, everything is it copies the same name. It's fcos. So we have to change this. So we have to prepare to say this and VFNet. Change here, and we go here. We do the same thing, and then afterwards we will refine. Okay, so let's change everything. So those names are not correct for now, but we will fix them afterwards. So just to make sure, we want to do everything to rename. And here, what is going to happen is that I need to add this one. VFNet. Okay. You can interrupt me at any time, okay? If something is not clear, you have just to interrupt me. Okay, so here what I'm going to do is that wait, there's someone who is joining. Where is it? Okay, okay, back to, okay. Maybe I will repeat very quickly for the one who just arrived. So what we did right now, we went to model under MMDet. Okay, I'm going to very quickly go back. I'll go to IceVision, model, MMDet, then go to model again. And what we did now is just copy fcos, make a copy, and rename it to VFNet. And now we are just renaming everything that was referring to to fcos. Earlier, we are renaming it VFNet. Okay. So the most important thing here is that under backbone, this ResNet FPN, it's there where we are going to add. For each backbone, we need to add the configuration, file name, path, and the weights. So for the, we can see here for each, let's take the ResNet 50. So for each it's not a backbone, it's a model, the configuration of our model. For each model, so here it's a ResNet 50. So for each backbone, we create a configuration. And then here we are going to, it's already done by MMDet. So we need to refer to tell IceVision where to find this file, okay? And this is how we do it. So what we do is we take a base URL, because all the pre-trained or the configuration files and the pre-trained, they have the same like URL part. It refers always to something like this, and then VFNet to fcos or something like that. So what I do in general is I open the MMDetection. I will go back to see where I find it. So let's go to the root of MMDetection. Under MMDetection, there is configs. Under configs, we have the different models, and we can see that there is VFNet. It's here. We click here. You see, those are the same thing that I was showing you under VS Code. So, but we have to go to the bottom here to find all the pre-trained models. So what I do is I come here, I right-click, and I copy the address and go back to. So just to simplify things, let's remove all this. Okay. And then we remove all this. And now we are trying to, so for now, these file names are wrong because they refer, it's a mix between ffcos and we just replaced fcos by a VFNet. So what we have to do, you can see that the base URL is this one. So just to avoid copying all the time, we put it here, okay? So what I have to do is to copy this and put it here. And then do the same thing. You can see here, we have the convention of calling ResNet 50, and they have the convention of using R50. We use ResNet 50 because TorchVision also use the same naming, explicit name. So what we have to do is to paste here, remove, and we remove Coco, and remove this, and this one has to be ResNet. Okay, and the second thing is to go back. So this is the config, and this is the pre-trained weights. So I do the same thing, copy the link, go back, and add it here. And here it's the same thing. In order not to repeat the base URL, I will copy from here to the end, go here, paste it here, remove this, and now we should have. So you see here we have a wrong name because this name comes from FCOS. It's just copy and paste. So we have just to do this here. Why it's showing this things? I don't know. Is there something wrong here? No idea. Okay, anyway. So, and we continue the same thing. For example, if we want another one, we copy this and go back and do the same thing. Come here, copy, go back, same thing. So I will copy this here. And this time I'm going to take just this part. I don't need the whole thing. And that. Go back. So it's more like manual labor here. And do the same thing. And then do this. And then copy this. So we have now our stuff here. Okay. So that's it. We have just to continue the same procedure to for the remaining models, pre-trained models. So what we can do now is just to switch to the one that I created, and hopefully, okay, I need to. So let's summarize what we did. And here, by checking the difference, we will have a better idea what we are adding. So here, what we did, we add a new folder. So let's recap here. So we had FCOS. FCOS, we copy it. We made a replica here, and then we rename the replica with VFNet, and we renamed everything that was referring to FCOS with VFNet. Okay, so we add VFNet here because we need to import the model, and you see those are the models that are supported right now in IceVision. Then here the same thing, we need to refer to VFNet. So those are copied, filed, and we just replaced with FCOS. FCOS replaced FCOS with VFNet. And this is actually the backbones, the different backbones that will be supported now with IceVision. We create them by going to the repo and get the file names from the repo for the config file and also for the pre-trained weights. Okay, so let's add a message, added VFNet. Then what we can do, I'm going to close this. I go to the one that I already prepared, and hopefully it's still there.
Yeah. Can I just have a quick question?
Yes.
How come I see for the first two models, the CornerNet and the Centripetal-net, there's no backbone folder like the rest?
Here, yeah, this is because I started to the support for Centripetal-net, and then I had some issues there. And this is why it's actually unfinished.
Oh, I see, I see.
I need to go back, and now that I find a way to expose the config, I can debug it easier. So you're right. I have a branch here, I think, where okay. They have two forks. Okay, so it's not in this fork. Okay, but you're right. I have to go and revisit that. But if you go to the other one, every single like folder has to have like the backbone and the ResNet FPN. Okay, sparse-rcnn and so on and so on. Good. Does it answer to your question?
Oh yeah, great. Thank you.
Okay, perfect. So what I did is that I went here like last night and I added all the different pre-trained models. So for each model, let's say for each model, it has like a different backbone. For example, this is a ResNet 101, and then this is a ResNet 50 with an MD-conv and so on. So it's like a variants, different variants. So if you are curious to see how it looks, you can go here and you see, for example, this is the basic one. Usually the basic one, it's an Air 50 FPN 1X. And what does it mean 1X and 2X? It just means that they train the model for 12 epochs when it's 1X and 24 epochs if it's 2X. Okay. And then you have to check like the different differences between the different configuration files. So all the MMDet models, they have like a familiar structure. So it starts with a model, it's a dictionary, it has a backbone, it has a neck, and it has a bounding box head. And then they use this also, the train and test that we don't use, but they. And the other thing, it's the same thing for train pipeline. These are the transforms, but we don't use them. Maybe at a certain point we can add that, but for now we have argumentation and we have our own stuff there. Okay, and same thing. There's also an optimizer, but we are using the optimizer of FastII or the optimizer in PyTorch. Okay, so you see what I said. 1x max epochs is 12. If we go to 2x, I should be able to. Oh, it's. You see, it can inherit from another one. That's the beauty of this configuration, is that you don't have to repeat yourself. So this is Air 50. So the Air 52x, Air 52x. Yeah. So, and then they override there. You see, max epochs is 24 as opposed to the other one, 12. Okay. So now that we have everything configured, what we can do. Yesterday I tested it I tried to test it here on my notebook, but since I don't have the GPU on this laptop, it didn't work because I think it was the deformable ConvNet that it doesn't have like a CPU version. So I went on, for example, Colab, because that way we can show how it works. So what I did to test, so I just copied the getting start. So you go and do copy to drive, and then you start the installation like usual. And then here I'm installing the new version. It's from my branch. So I'm reinstalling. Here it installs the IceVision from PyPy. But in this case, we need to install it from my branch, not even from the master, because the master doesn't see my branch yet. So I'm installing. This is how I just clone from my account, and then I choose which branch. So MMDet VFNet support. If I go here, it's the same thing, MMDet VFNet support. Okay, and then it will install. This is very important. You have to restart your notebook, otherwise you won't see the changes. And then you import. Here the import went well. Let's go and do the usual thing. Okay, let's this. So those are the same cells from the original notebook. Okay, we get here. I'm going to comment this because that was just an experiment that I wanted to do. So this is what changes from the original notebook. In the original notebook, if you check, you will see that we are using RetnaNet, and this is the backbone that we are using, ResNet 50. So here we have just to remove Retna, replaced with VFNet, and it turns out that it has the same name. The backbone has the same name, so you don't even have to change this line. Okay, so we go like this. So this is just to double check that the model comes from VFNet. And this is if you want to get the dictionary, that's how we create. So you see, just to make the link with here, You see this ResNet FPN 1x. This is how it will become once you expand with the base URL and so on. So this tells IceVision where I can get my configuration file. Okay, so and this tells also IceVision where to get the weights. So this is the whole URL. Okay, once it's done, create the model, and here it's going to download the pre-trained weights, put them on your local machine. So here it's a virtual machine, but it will be saved. So next time if I want to recreate the model, it will skip the downloading. Okay. So once it's done, then we continue just like usual. We go with the create the data loaders, and once the data loaders are ready, we can. What's going on? Friday, 13th. Why it's not? Yesterday it worked.
So theoretically, it should also work with other models on MMDetection as well. Or is there like some models that we need to also change certain thing in the init file itself?
You mean to adapt to IceVision?
I mean, like does this like guide will also work for like other models on MMDetection as well?
Sorry, but I didn't understand the
Oh,
question. What you are asking is that for if we want to add support for other models,
do we also
or
just
are you?
yeah. So do we just do the same thing like changing the backbone file only?
Sorry, I missed. There's what's happening. Can you hear me?
Yes.
Yeah. Suddenly it cut and I couldn't. So here, what we need to do is to change the model name. So to tell IceVision I'm using VFNet, and I'm using the ResNet FPN, the ResNet 50. So this ResNet FPN, like its architecture is the same thing than the one for RetinaNet. You see?
Oh,
So to be sure that what you have to do is just change here the model name VFNet, and the rest the configuration will be the same. If you check, for example, if we go here, this is a ResNet FPN for VFNet. Do I have one for? If I go to RetinaNet backbone, MMDet, what's happening? Oh no, it's here. Okay. So you will see that it has. It's the same structure. They are like quite similar. The way that they are defined, And even if we go to MMDetection, we will see the same thing here. Here it's VFNet, and if I go to Retina, here, no, you see RetinaNet is it's in the base, defined in the base. So we go to the model here, RetinaNet. Okay, so let's go like this, and then you see they are quite similar actually. And by the way, VFNet, they were inspired by FCOS and ATSS. So if you want to really compare, better to compare with but the backbone are exactly the same, almost exactly the same thing. So where is it? You see, let's move maybe like this. Then yeah, you see, backbone, ResNet, depth 15, number of stage 4, out of indices, it's the same list. Frozen here, batch norm is the same, and that's it. So they are quite similar in reality. Okay. Does it answer to your question or?
yes. But what I mean is like, would if I want to add like further models from MMDetection that is not supported yet, like would it be like similar steps like this?
Yes, exactly. Let's say you want to add, I don't know, so we can go through MMDetection. This is not like particular to a VFNet. It's, let's see, in the list here, you decide to say, okay, I want to use ATSS, okay? Because ATSS, it's similar to also to FCOS and VFNet. So what you will have to do is you go to ATSS, so first one here, and it's the same thing. We can't even do it, because there's just two.
Okay.
You see what I mean?
Yeah, great. I think I will try more later on. Sorry, are you
I
saying?
didn't hear
Oh,
the next part, the part of
oh, yeah, yeah.
your sentence.
I think I will try more models later on and test. I think if I succeed, think I can add more to the library.
Yeah, that would be great. And this is I think if we can have like more people who could help to add the the different models, that would be great, because you can see that it's a pretty straightforward procedure. And now and then we will have like some roadblocks, because some models are like more complex than others and so on. But we will try to figure out how to fix or how to support them through a discussion in the forum. So that would be great. What I'm intending to do is that once we have the video, I will produce I will edit it, and then I will put it on YouTube, and then people can use it as a guide to be able to contribute in adding more and more models. Okay.
Yes, that would be great.
Yeah. So I don't know what happened here. Whoa, this and for. Okay, let's try to do it again, because this pytorch stream reader fail. What is this? Yesterday it worked. Now it doesn't work. Weird. Let's see. This is why I wanted to prepare my stuff yesterday, just to make sure that. Okay, let's go to the notebook, where at least we can see that we can load the model. Where is it? I'm under IceVision. Okay. Control E. What is this? Getting. Yeah, that's better. Okay. One thing that we can do. Let me see. That's a bit really strange that it does that. Come on. Oh. Okay, let's use the hammer. Let's see. Let's see. Okay. Here, and then go back to the other side. Okay, this is what I tried to do yesterday. I don't think that it will. Here it's going to take time. Okay. So, what is this? PyTorch. Never saw this thing. Man. Oh. Oh man. Don't even know what to. I don't think so. No. Okay. Sorry about this, but okay, let's here. Okay. Okay. So you see here, it already loaded my file. Is there a way to do it manually?
That pytorch error, I think, came because
Yeah.
of invalid. Yeah, this one I touched you. Came because of corrupted weight. So maybe it did not download properly.
Yeah.
So
I'm trying to remember which folder it where does it? Okay. Checkpoint. Okay. Let's do it differently. PyTorch. Okay. So ls. Okay. Let's do this cd checkpoints. Okay. Oops. Oh, it's there.
How about you try with another backbone then? See what happens.
Sorry?
How about you try with another backbone then? Maybe
Another backbone?
yeah, of
Yeah.
maybe ResNet FVN2X or something. Maybe it
Yeah.
does that fine.
Yeah. Let's do that. Where is it? This one. Why not? That. I'm going to make sure that it's not right here. Okay, that's good. Thank you for the suggestion. I don't understand. But earlier it did the same. Show batch. It's not that important. Okay. It's good actually. Then I can compare with the test that I did yesterday because I kept a screenshot from. I should once we merge it, I can use 1DB to track the different backbones and so on. Let's do this. Go like this. I'm going to show you what I did yesterday, and it's quite interesting because this is the VFNet, the ResNet 51X, and you can see that after 12, it reached 90. And if you remember one of my posts lately, was it here? This is with RetinaNet, but by changing the weight of the loss. So the weighted loss, you change the the attributes. And here, this is like equal weights. It gives 85. And if you use for the loss box, if you use the weight of 2, it jumps to 91. So this is like a bit similar. So I was wondering. So what I did here, I took just the LRMIN that is suggested here by FastAI. We're going to see the results that related to this backbone. It starts at 41. Let's check the other one. Oh, I cannot see it. Okay. 41. Wow, it jumped to 84. That one. Oh, wow. I'm surprised.
I think Google Meet just announced we only have 5 minutes left or something.
Sorry, can you repeat?
I think Google Meet just say our free call is ending in 4 minutes.
Oh, then I have to restart a new one and then we join. Once it stops, this is what I'm going to prepare, like send another one on the forum. I didn't know that they cap you at 1 hour or what. Anyway, I think we're almost done there. And as you can see, everything is working well. What I'm going to do, the next step that I have to do now is to go to IceVision, and I think, did I have? Oh no, my pull request didn't show up here. Okay, I will submit it later. So today I'm going to merge already VFNet, and that way you can play with it too. So 94. Interesting. That would be great if you can test your models with VFNet, especially with this one. So it was good that we had the error there with with PyTorch. So we are using this one. Still, it's a ResNet. MS train 2 times. So this one is trained like for 24 epochs instead of 12. Okay. Are you still there?
Yes. I
Yeah.
think actually it's still under fitting. Actually, I think you can fit more than maybe even the higher metric. Because the
Yeah.
gen law is still higher. But
It's quite impressive, actually. It's 95.58. And it's not, it takes just 5 seconds here. It's just, if we compare with the RetinaNet, usually I think it's like 5 seconds. So there's not like a huge difference in terms of computation. So that's great. Good news. So is there any questions?
I think for me, no. I think I will try it tomorrow.
Okay. So can we say that once the call is ended, the presentation will end, or do you need more time for questions? Or
I
It's
think,
done.
sorry, I think you can focus.
we can continue? I can show you the paper if you want, and just to give you an idea of maybe what we can do is to stop this call and start another one, and I can go and show you very quickly what the explanation why this model is getting better result than FCOS, for example, or RetinaNet. Or okay, would you like to do that?
Yeah, I think that would be interesting.
Are you familiar with VFNet?
To be honest, I haven't read the paper. I just use it based on the
Okay.
benchmark result.
Okay, no problem. Okay. So what we can do, I'm going to give you like a very brief overview of the paper. I didn't have time to dig deeper, so I read it very quickly yesterday. So you need to go and read like in more detail if there are some parts that are not very clear. But so let's see here. This is no, this is ATSS, and this is the VFNet, the varifocal net. What they did actually is that what they say that usually what we do is that when we select our like bounding boxes, we use the class label as as a selector for our anchor box. We say, okay, which one, which class has the higher confidence, and from there we are going to select the let's say it selects a cat that has the highest confidence, and then we go and and decide, calculate the try to select the anchor boxes, the proposal. How can I put it? We choose our proposals boxes by selecting the highest confident label. Okay, so what they say is that this gives more importance to the class instead to the proposed box, because it may happen that you have a box that has an IU higher, and it will be discarded because it has like a lower confidence. Its label has a lower confidence, so you are going to eliminate like a potential good box. So to try to solve this problem, what they say, we should combine the confidence, so the score label, with the score with your IU, and there's here. So what happens is with FFCOS, for example, what they did, you have the class score, and they added also the localization score, but they use them separately. But for this model, what they do, they say, instead of predicting an additional localization accuracy score, we can merge it into the classification score. So they are asking, can we do that? That is predict localization aware. So it's an IU aware classification. So it doesn't rely just on the classification score, but it relies on the combination of the IU and the classification. So that simultaneously represent the presence of a certain object class, like I showed earlier there, and the localization accuracy of a generated bounding box. So when you generate a bounding box, like a proposal that your model proposed, you're going to take into account its classification and also its localization. And its localization is represented by the IOU. Okay, and that improves like the one of the element of the improvement here. And the other thing is that, so if we check the way the architecture of your model here, so here let's check first what it looks for FCOS. For FCOS, so this is like the regular thing that we know now. You have the backbone, you have the feature pyramid network, and the head, and for each head, you have like a branch for the classification. So for FCOS, they have classification, centerness. Centerness, it's the localization score. So those are two different scores that are separate for FCOS. And then you have regression, and regression will give you like your proposal of your bounding box, So for FCOS, we have two. In reality, in the latest version of FCOS, the centerness, they bring it here. And they put it in the same branch as the regression. But this is just a detail. So for VFNet is largely inspired by FCOS and ATSS. Okay. So if we go back to VFNet, so we have also the same structure. It's very familiar. And then here we have three branches. So we have an IU-aware class score, like in the other one. So there we have just a classification, but here we have an IU-aware. Okay. And then here, this one would be a regression. And what they add is the refinement. So in a way, it's like this part should be like very familiar to taking this and combine them together, okay, to have the IU aware classification score. Okay, and then what they add is a bounding box refinement. So what they do is they have another branch that's try to refine your proposed box here. So if the proposed box is this one, they are going to try to refine it by trying to figure out the offsets here. So that's one of the elements. So we have like already two things. The IU aware classification score, the offset, which is the refinement of the box, and also what they do, they have 9. It's like 9 key points here, or points that your model try to predict. Okay, in FCOS, it takes just this one, the center. It tried to detect the center, and it regress the left and right to the true to the ground truth, and the up and bottom to the ground truth. Okay, but here they add this one, this one, this one, and this one. You have more. Okay, so this is how we. And another trick that I noticed yesterday on their config is that if you go to the loss, I'm going to close this, is that they have the loss for classification, the weight is 1. The loss for the box is 1.5, and the loss for refinement is 2. You see? So they are using a true weighted loss. Okay? It's like a bit similar to what I suggested in the forum. In the MMDet, I just tried this. I gave like the double of the weight for the B box loss, and I reduced the one for corresponding to classification. This is how, like, all the tricks that they are using for this model, and we ended up having like a better results. And as you can see, if we want to compare exactly with the FPN, the ResNet FPN 1X, you can see that it reached 90 already after 12. And if we compare it to the one of RetNet reached 85. Okay, the one that I suggested reached 91%. So the VFNet seems to be even better. And the one that we just tried now, the second backbone, still a ResNet 50. You see that it reached 95. Well, this is a toy data set, so all the conclusions should be like we should take them cautiously and not overgeneralize what we see here for just the fridge data set. Is there any question?
Not related to this. I just had a general question. Uh, means, I just wanted to know, like, what would you prefer, like, if you had the most important criteria for your model as the inference speed or the FPS, which model would you suggest in that case for object detection? So,
For FPS,
yeah.
the frame per second, it seems like
Yes.
the YOLO V5 gets a very good result because, and has also a high, how do you say, accuracy. Are you familiar with VFNet?
To be honest, I haven't read the paper. I just use it based on the benchmark
Okay.
results.
Okay, no problem. Okay. So what we can do, I'm going to give you like a very brief overview of the paper. I didn't have time to dig deeper, so I read it very quickly yesterday. So you need to go and read like in more detail if there are some parts that are not very clear. But so let's see here. This is no, this is ATSS, and this is the VFNet, the varifocal net. What they did actually is that what they say that usually what we do is that when we select our like bounding boxes, we use the class label as as a selector for our anchor box. We say, okay, which one, which class has the higher confidence, and from there we are going to select the let's say it selects a cat that has the highest confidence, and then we go and and decide, calculate the try to select the anchor boxes, the proposal. How can I put it? We choose our proposals boxes by selecting the highest confident label. Okay, so what they say is that this gives more importance to the class instead to the proposed box, because it may happen that you have a box that has an IU higher, and it will be discarded because it has like a lower confidence. Its label has a lower confidence, so you are going to eliminate like a potential good box. So to try to solve this problem, what they say, we should combine the confidence, so the score label, with the score with your IU, and there's here. So what happens is with FFCOS, for example, what they did, you have the class score, and they added also the localization score, but they use them separately. But for this model, what they do, they say, instead of predicting an additional localization accuracy score, we can merge it into the classification score. So they are asking, can we do that? That is predict localization aware. So it's an IU aware classification. So it doesn't rely just on the classification score, but it relies on the combination of the IU and the classification. So that simultaneously represent the presence of a certain object class, like I showed earlier there, and the localization accuracy of a generated bounding box. So when you generate a bounding box, like a proposal that your model proposed, you're going to take into account its classification and also its localization. And its localization is represented by the IOU. Okay, and that improves like the one of the element of the improvement here. And the other thing is that, so if we check the way the architecture of your model here, so here let's check first what it looks for FCOS. For FCOS, so this is like the regular thing that we know now. You have the backbone, you have the feature pyramid network, and the head, and for each head, you have like a branch for the classification. So for FCOS, they have classification, centerness. Centerness, it's the localization score. So those are two different scores that are separate for FCOS. And then you have regression, and regression will give you like your proposal of your bounding box, So for FCOS, we have two. In reality, in the latest version of FCOS, the centerness, they bring it here. And they put it in the same branch as the regression. But this is just a detail. So for VFNet is largely inspired by FCOS and ATSS. Okay. So if we go back to VFNet, so we have also the same structure. It's very familiar. And then here we have three branches. So we have an IU aware class score, like in the other one. So there we have just a classification, but here we have an IU aware. Okay. And then here, this one would be a regression. And what they add is the refinement. So in a way, it's like this part should be like very familiar to taking this and combine them together, okay, to have the IU aware classification score. Okay, and then what they add is a bounding box refinement. So what they do is they have another branch that's try to refine your proposed box here. So if the proposed box is this one, they are going to try to refine it by trying to figure out the offsets here. So that's one of the elements. So we have like already two things. The IU aware classification score, the offset, which is the refinement of the box, and also what they do, they have 9. It's like 9 key points here, or points that your model try to predict. Okay, in FCOS, it takes just this one, the center. It tries to detect the center, and it regress the left and right to the true to the ground truth, and the up and bottom to the ground truth. Okay, but here they add this one, this one, this one, and this one. You have more. Okay, so this is how we. And another trick that I saw, that I noticed yesterday on their config, is that if you go to the loss, I'm going to close this, is that they have the loss for classification, the weight is 1. The loss for the box is 1.5, and the loss for refinement is 2. You see? So they are using a true weighted loss. Okay? It's like a bit similar to what I suggested in the forum. In the MMDet, I just tried this. I gave like the double of the weight for the B box loss, and I reduced the one for corresponding to classification. This is how, like, all the tricks that they are using for this model, and we ended up having like a better results. And as you can see, if we want to compare exactly with the FPN, the ResNet FPN 1x, you can see that it reached 90 already after 12. And if we compare it to the one of RetNanet reached 85. Okay, the one that I suggested reached 91%. So the VFNet seems to be even better. And the one that we just tried now, the second backbone, still a ResNet 50. You see that it reached 95. Well, this is a toy data set, so all the conclusions should be like we should take them with cautiously and not overgeneralize what we see here for just the fridge data set. Is there any question?
Not related to this. I just had a general question. Uh, means, I just wanted to know, like, what would you prefer, like, if you had the most important criteria for your model as the inference speed or the FPS? Which model would you suggest in that case for object detection? So,
For FPS,
yeah.
the frame per second, it seems like
Yes.
the YOLO V5 gets a very good result, because and has also a high how do you say accuracy and a high FPS. So it's like the combination of two is good. And
Okay.
in terms of precision, it seems like EfficientDet right now has very good results, especially with like a D3, a D4, D5. But
EfficientNet,
sorry,
EfficientNet is the backbone, right? With which head?
like D3 or
Okay.
D4, or because the higher you go, the higher accuracy is, but the FPS will decrease at the same time. So one thing that it's interesting to do when you read the paper is to go the most, like, in general they give the FPS, so let's check here, for example. So not all the models give FPS. So you see EfficientDet D6, but this is a huge model. Okay, so it's 5.3, D7 is 3.8, ATSS it's 17. So let's see VFNet. VFNet seems to be interesting. So for example, the one that we tried, it must be around 19, I guess, because they don't give the R50, the other one. So I don't know exactly that. But you can
With
see,
so this is tested on which GPU? Like, is it written?
I guess so. It should be, so Yeah, that's the thing, is that they cheat a bit because they always give you like results with the FPS with the GPU. Let's see. Yes. Yeah,
We
you
can get.
see,
Okay.
NVIDIA V100, not anyone. You see, so, but you see the 19. This is what we were saying. It can be seen that R is very achieving. So this is a very good AP, but
Okay.
at the same time, it's NVIDIA
So if you
V100.
compare YOLO V5 with this, what is the AP for that? Just
I don't recall the ones of V. We should have them in the forum, I think. The problem here is that it's too. It's because YOLO V5, there's no paper there, so
yeah.
you have to. Oh, so, but I think it's there on the repo. They have benchmark, I think, somewhere. Okay. No FPS.
No, they have flops.
Yeah, just flops. But faster. What is this? YOLO. Is it FPS or what?
So GPU transfer. I think
So
it's
this is
talking about flops.
GPU speed millisecond per image. Okay, so that can be translated to the FPS, I guess.
Yeah.
So where are they? YOLO 10, 12 millisecond. So yeah, then you have to convert it to the. They don't give an FPS, which is.
No, that's fine, but they do give us the comparison, so I can easily do that. Right? So it's
Mhm.
10 milliseconds. Thousand divided by.
But I think they have like a page where they have their benchmark.
So if it's 10 milliseconds, it's around 100 FPS on whatever GPU they are tested.
Mhm. Yeah, I have just to convert. I know, but maybe in their documentation, I don't know. No. Yeah.
Okay.
So yeah, you have to check.
Okay. Okay.
But in general, they don't say that.
No, but if you see
On
the
CPU.
AP, like if you just go down and see the AP in this, you see that it's pretty good. It gave around 50 or
It's high. It's very
yeah.
high. It's
So
higher than VFNet, that's for sure. You
yeah.
see
So it
the V5 is 54. This is TTA. So anyway, yeah, you should check
so
there.
even with like lower parameters and they are getting around 43 and 50 FPS. Sorry, MEP, which is
Mhm.
good. I don't know the data set they have tested it on, but if
I suppose it's Coco.
if it's
Otherwise,
comfortable, it's good.
yeah. Otherwise, yeah,
Yeah.
Coco.
So, yeah. So this breaks the like VFNet and other MEPs that we see. So just a question, like I see that IceVision recently converted, added YOLO V5. So did it give anything similar result?
S- Sorry, I couldn't hear you because there's like a background sound, and I had a hard time to hear you.
Okay, so I just asked, like, I just noticed that IceVision recently converted YOLO V5, added YOLO V5. So did you guys get similar results on this, or this is
Somewhat. Sorry.
similar results on YOLO V5?
Oh, one thing that we don't know that we don't do is their data augmentation. For example, they use mosaic and so that might have like an impact on the result with IceVision. You see,
Okay.
and auto anchoring. There is Rahul who shared how to use it in IceVision, so that should help. And I know that yesterday he was answering to someone about it. Okay, maybe it's in IceDev. Don't see it. Let's do a search. Search YOLO. Uh, it, it's here. So Rahul, he shared this. how to use how to add auto anchoring to IceVision here. So you can use that for now, and hopefully we will like integrate that in IceVision. So,
Okay.
but we don't have Mosaic, for example. You see.
Okay.
Yes.
Okay. Thank you.
You're welcome. Good. Is there any question?
Not for me.
Okay. So that's it. If there is no other questions, we can wrap up. And Kao, if you can like post the link to your to the video files, maybe
Sure,
on
sure.
your Google Drive or anything that can be accessible, then I will download it and then I will edit the video and then I will post it in hopefully soon on our YouTube channel. Most likely at the beginning and listed, and then we see that. But at least the devs, they can have access to it through IceVision forum. Okay,
Sure, sure.
perfect. Are there
Okay.
any other
Thank you.
questions? Sorry.
Thank you.
You're welcome. My pleasure. So hopefully this like set the pace to our new to other models that we can integrate in IceVision, other MMDet model. And as you can see, it's pretty straightforward. And if you have any questions, you can post on the forum, and we can solve them together. But I don't expect like major problems, especially if the models are very similar to FCOS and RetinaNet and faster-rcnn and so on and so on. Maybe some models can be more challenging when you have like several heads and so on, and you combine them in. So, but anyway, I think for the vast majority of the models, we would be able to integrate them, and that would be great if you can, like, contribute and submit PR there, and then we can add them. This afternoon, I'm going to merge VFNet, so you can have access to it already today. So, if you don't have any question, I will just end the call and wish you a great weekend.
Sure. Thank you.
You're welcome. Have a good weekend.